Hey everybody, this is Mr. Schaefer, and this topic is going to cover a variety of the parent functions, the primary families of functions that we're going to encounter in pre-calculus. So we should know about the domains and ranges of these functions, and in general what they look like and what their algebraic equations look like as well. So in this document here, I have graphed a series of 8 different families of functions. And when we say family of functions, we're just talking about graphs that display one or more similar characteristics. And the parent function is going to be the simplest function within that characteristic of the family. So for example, the first one here, actually the first 2 examples are both linear functions. Number 1 specifically is the constant function, and that's simply a horizontal line. The equation of this function would be simply y equals 4. Or in function notation, we could write that as f of x equals 4. And the domain and range, domain is defined for all real numbers, so negative infinity to infinity, but the range is simply the output of 4. It's never going to be any number except for the number 4. Now, the linear function here, this linear function is not constant, it's actually increasing. So the equation here would be y equals x, or f of x equals x. Think of y equals mx plus b. In this specific example of the picture, we have the m slope is 1, and the y-intercept b value is 0. So y equals x would be that equation. Its domain and its range encompass all real numbers. Now let's look at some examples of functions that are just a little bit more complicated than the linear functions. And these two are polynomial functions. We have the x squared quadratic function in number 3. And number 4, the x to the 3rd cubic function, x cubed. Now for all polynomials, the domain and range will be the same, all real numbers. There we go. Here are some more examples. Function number 5 is called the absolute value function. So its equation is simply y, or f of x, equals the absolute value of x. Notice that in this picture we have symmetry across the y-axis. Its domain is all real numbers, but be careful with the range. Lowest to highest would be 0 up to infinity. Close bracket the 0 because 0 is included in the range of this function. Number 6, the square root function, that would simply be radical x, the square root of x. Its domain begins at 0 and goes to infinity, and its range also goes from 0 to infinity. So staying here in quadrant 1 throughout. Which brings us to the final 2 function families that we're going to learn about. And in number 7, it's not quite completed yet. The reciprocal function actually exists in both quadrant 1 and over here in quadrant 2. Let's try to draw that in there for us. And there's a vertical asymptote that goes right through the middle of our picture. That vertical asymptote is x equals 0. I'll put VA for vertical asymptote. And its equation here is simply the reciprocal function 1 over x, where x is in the denominator of the function, of the fraction. Domain, all real numbers except for where the vertical asymptote is, which is 0. So negative infinity to 0, and then 0 to infinity. The range would be the exact same. The lowest it goes is negative infinity to the y, but notice that the y value never hits 0 exactly, so we're going to partition that range off as well to go from negative infinity to 0, and then once again pick up from 0 up to infinity, but not including 0. And then the final family of functions here is one that's known as the greatest integer function. And it's a little bit of a funny notation. We have the input variable is in these square closed off brackets. It's defined for all real numbers, but the range is only integer numbers. And in mathematics, we have this capital bold-faced letter Z right here that represents all the integers. So no matter where you are in this function, which is sort of looks like little stairs, increasing steps or stairs, you're always going to be exactly on an integer. Integers are numbers that are not decimals or fractions. They can be negative, they can be 0, and they can be positive. -5, +2, but a number like 1/3, which is a fraction, or a number like 7.6 would not be considered an integer. So the range is all the integers and only the integers for that type of function. So these are 8 examples of some of the more common families of functions that you might see in PreCalculus, and there are others, but these parent functions are a good place to start for this unit.